Let me ask you something. That picture you have in your head of the universe, you know, the one full of stars and galaxies and planets, well, it turns out it's almost completely wrong. Everything we can see, everything we've ever touched or measured, is just a tiny, tiny fraction of what's actually out there. Take a look at this number, 4.9%. That's it. According to our very best cosmological models, this represents all the normal stuff in the cosmos. It's what scientists call baryonic matter, but really, it's just everything made of atoms. It's you, it's me, the Earth, the sun, and literally every single star you can see in the night sky. And yeah, that immediately leads to the single biggest, most mind-bending question in physics today. If everything we know is less than 5%, what in the world is the rest? This is the central mystery we're going to investigate. Think of it like a cosmic detective story, where the clues are hidden in the motion of galaxies and the very fabric of space and time. Okay, let's dive right in. Our journey really begins by having to accept a pretty startling fact. The universe we perceive is just the tip of a colossal, invisible iceberg. You see, for decades now, astronomers have been gathering clues that just don't add up. All across the cosmos, they've been observing gravitational effects that are way, way too strong to be caused by the amount of visible stuff they can account for. It's like something massive and completely invisible is out there pulling the strings from behind the curtain. So where do we find our first major clue? Well, it comes from simply watching how things move, specifically the really strange way that entire galaxies are spinning. The first person to realize something was off was an astronomer named Fritz Zwicky, way back in the 1930s. He was looking at galaxies in the Coma cluster and saw they were moving so fast they should have just flown apart. He's the one who coined the term dark matter for whatever unseen mass was holding them together. But honestly, the idea didn't really take hold until the 1970s when Vera Rubin came along and found the smoking gun. Rubin meticulously measured how spiral galaxies rotate. Now, based on everything we know about gravity, stars on the outer edges should be moving much slower than stars near the bright, dense center, but that's not what she found. The stars on the very edge were zipping along just as fast as the ones on the inside. So here's the kicker. The only way this is even possible is if the entire galaxy is embedded in a massive, invisible halo of matter that provides the extra gravity needed to hold it all together. Our next piece of evidence comes from one of Albert Einstein's most profound predictions. His theory of general relativity tells us that gravity actually bends the path of light. This means a really massive object, like a galaxy cluster, can act like a giant cosmic lens, warping the light from more distant objects that are hiding behind it. And astronomers are pretty clever, so they can use this effect to their advantage. By mapping those distortions, they can basically weigh the galaxy cluster and see where all its mass is really located. And time again, these maps show the same thing. The vast majority of the mass is not where the glowing stars and gas are. It's in a huge invisible halo surrounding them. I mean, this gives us a direct visual confirmation that this dark matter stuff is real. So, just as scientists were starting to wrap their heads around the reality of dark matter, a discovery in the late 1990s introduced an even more bizarre plot twist that completely changed our understanding of the entire universe. So you had two independent teams using this special kind of exploding star, a Type I supernova, to measure the history of cosmic expansion. Now, these supernovae are cool because they'd always explode with the same intrinsic brightness. That makes them perfect standard candles for measuring vast distances. And pretty much everyone expected to find that the universe's expansion was slowing down, being pulled back by the gravity of all the matter inside it. But they found the exact opposite. The most distant supernovae were fainter than they should have been. This meant they were farther away than predicted, which could only mean one thing. The expansion of the universe isn't slowing down at all. It's accelerating. Something was actively pushing the universe apart, overpowering the force of gravity on the largest scales. And they called this mysterious force dark energy. So, our cosmic investigation has now identified two prime suspects responsible for the missing 95% of the universe. So let's take a look at their official profiles. Now, check out the modern budget of the universe. This is just wild. Dark energy makes up a staggering 68%. Dark matter makes up about 27%. And ordinary matter, again, that's everything we've ever seen, is less than 5%. We are just a tiny little bit of cosmic foam on a vast dark ocean. This really brings their profiles into sharp focus. Our two suspects have completely opposite effects. Dark matter is the cosmic sculptor. Its gravity pulls things together, forming the scaffolding that galaxies and clusters are built on. Dark energy, on the other hand, is a repulsive force that seems to be part of space itself, pushing everything apart and driving that runaway expansion. One builds, while the other separates. Understanding these two mysterious components isn't just some abstract puzzle for physicists. The battle between dark matter's pull and dark energy's push is actually what will determine the ultimate fate of our entire universe. The future all depends on the true nature of dark energy. If it's a constant property of space, the universe will probably expand forever into a big freeze, becoming endlessly cold, dark, and empty. But if dark energy grows stronger over time, it could lead to something called a big rip, where its repulsive force eventually becomes so powerful that it tears apart galaxies, then solar systems, and finally the very atoms we're made of. So we're left with this really humbling realization. The two dominant ingredients of our cosmos are things we can't see and don't understand. This cosmic mystery forces us to confront the absolute limits of our own perception and ask a pretty profound question. Is 95% of reality destined to remain forever in the dark? It's an incredible reminder that the more we learn, the more we realize just how much is still left to discover.